Welcome to everyone for joining us today for our webinar. I'm the Technical Sales Manager at Spark here in the UK, and I'll be your host for today. And I'll be handing over shortly to Ed. But today we'll be presenting tips and strategies on how to select the right Inlet Works equipment, presented by Ed Greathead, our screen expert, and Bruce Crawley, our screening and grit expert. We will cover a wide range of equipment available to Inlet Works around the world, starting with the selection of coarse and fine screens, different screening, washing and dewatering options, grit capture and washing, and possible storage and transportation solutions. Last but not least, we will show some Inlet Works examples we have designed and manufactured in previous years and current projects. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the Skype window, which we can then bring up at the end, and we can address those questions at the end. The webinar will be recorded and a link sent out via email, which will also include notes, links and videos mentioned during the webinar. Now, without further ado, I'll hand you over to Ed, our inlet screen expert with more than 15 years experience in this field.
Thank you, Rob. Thanks for the introduction, and hello to everybody joining us today from, I can see, from around the world. It's good to see you all. I'm going to start going through Inlet Works equipment selection, as we've said, and highlight some elements of obviously our equipment, but also just general points as we go. So the first things that I'm doing is going to be our coarse screens, and then followed by fine screens. As you can see there, we've tried to make the order of things being presented today as you would see them coming up in an Inlet Works. So if I proceed to my first slide, I have written an article in the past regarding the fact that on a lot of Inlet Works, people seem to forget about putting some kind of coarse screen protection up front of any fine screens, and then they end up maybe paying the price of having the fine screens damaged by foreign objects that might come down the sewer systems. If you are getting sewage from a gravity feed, or even very large pumping into your Inlet Works or Archimedes screws, then you can end up with large items of debris which you want to stop before it goes and damages your online equipment. Our first selection of coarse screening that you can see there is what we refer to as our rake guard screen. As it states there, it is a front raked bar screen. So we have a grid of bars, and the debris comes down the channel and hits the front of those bars. Ordinarily, we have those bars as a tapered profile. So the front face of those bars is usually 12 millimeters wide, and then it tapers down to 6 millimeters at the back of the bar. This means that the gaps between the bars are opening up as the water flows through. So it's only the front face that, I would say, does the work. What this screen has, it has one large rake, which, when the screen is sat gathering screenings, the rake is sat out of the flows, up around the discharge of the screen, waiting for the differential across the screen to produce a run cycle for that screen. Once that starts, the large skip rake goes down into the channel, at which point the actual combs that remove the debris from the grid, they are not engaged or meshed within those panels. The combs are totally free. So the rake travels to the bottom of the channel. There's a rotary limit switch on top of the screen which tells the controls that the rake has actually reached the channel. At which point an electric actuator actually pulls the comb beam and the skip into the grid bars, and then starts the upward movement of the skip rake gathering the debris that's collected on the bars and transports that to the discharge point of the machine. The debris is then removed from the skip rake by a wiper mechanism. So the entire screen does not require any wash water to function. Now these screens are usually used on quite large inlet works. As you can see there, flow range up to 2,500 litres a second, or they can be used on smaller inlet works, of course, just down to the type of debris that might come down the channel. So if you are expecting things like logs or maybe gas cylinders and things like that coming down your sewer, what this screen has is what we call a profiling function. So if something gets into the channel, like a log, that this screen cannot move because maybe the item is maybe too heavy or it's become wedged in front of the screen. The rake tries to lift that out 3 times. If it then cannot lift it, it obviously raises an alarm for the operators to come and have a look what's stuck in front of the screen. But the screen itself will carry on operating, and what it does is the electric actuator will move the rake out, and then the hoist mechanism moves the grid, the rake up, and usually about 300 millimeters before the electric actuator re-engages the grid, the rake into the grid bars and carries on moving. So the screen will actually keep on moving and profiling around any blockage before the operator can come out. It means that your Inlet Works carries on operating without stopping your process. I can see that I've got a question regarding what the weight capacity of the screen is. Really, that is going to depend on what size of drive motors and chains we will put on there. We tend to be looking like 12,000 pounds braking load for the chains, and these things will remove items such as like the car doors and your gas cylinders without any problem at all. That's the lost my train of thought now. The amount of weight they'll actually lift is quite substantial on each individual, because all our products are bespokely made. We can obviously advise what the rating of each screen would be. If I go on to the next slide, we've got another type of core screen that we can offer. This is our chain guard core screen. As you can see, it's a slightly different type of screen to the other one. These come as individual unit that can be installed in the channels as a single piece item. Once again, this is a front raked bar screen. There is a series of grid bars which collects the debris on the front. Now, unlike the rake guard, this particular screen has a number of comb beams evenly spaced over the length of a set of chains. So a pair of chains runs in chain guides at each side of the screen, and the comb beams are spaced between them. Once the screen becomes blinded and the screen is asked to run, the comb beams rake down the front, go down the front of the screen, and then as they go round the bottom chain guide, they rake up the front of the grid bars and remove the debris to the top of the screen to the discharge point, where again they are wiped off with a wiper. So again, no wash water required for this particular type of screen. And as you can see, the channel widths and the channel depths that we can go down to means that we can cater for lots of different flow ranges, and we can actually go down to something like a half a meter channel width if required on this particular unit. Unfortunately, at the moment, we haven't got any movies or animations of the screens to show, but what I've got next is some photos from our assembly facility, because we've got a couple of these units ready to be installed. So these particular units have currently been manufactured and ready for the client to be ready on his site. They are 2¼ meters wide and 11 meters long in total. So you can see at the head end of the structure is where the blue drive motor and gearbox is. So we only need one drive motor and gearbox. The bottom left hand picture shows the grid bars. You can see those as the shiny grid bars, and you can see the cone beams. One of the cone beams on the bottom of that drawing is engaged in the cone beams, so that would be raking up and taking the debris to the head of the structure. And the other cone beam that you can see, that is showing it in the position as it's coming down, ready to go around the bottom chain guide radius. So basically it is just a set of continuous chains with a number of grid cone beams spaced between them, and this carries on running round and round. What this does, it removes debris in a continuous method, thus transporting small amount, relatively small amount of debris at a time into the any screening handling units associated with this unit. Now, what I've said before regarding having obviously the coarse screen protection is you're not only stopping large items going down to the fine screens further downstream. A coarse screen with, say, a nominal 25mm bar gap would remove something in the region of about 20% of the screening's load coming into the works. So it could be a better solution to remove 20% by the coarse screens, and then let the fine screens actually deal with the remaining 8%, rather than overloading any fine screens. You would probably choose the chain guard where you've maybe got a lot of maybe rag debris and smaller debris such as, say, stones and rocks, because that, like I say, that removes the actual rags a bit at a time into the screen handling units. So that's an easier thing for any screen handling units to operate. Where I would choose the rake guard is where you have got a large gravity sewer coming into the works, where you would expect large bits of debris for the profiling function that the screen has got, and able to keep the works running if it does encounter a large object. Is how I would use that. So all our screens come in different material grades, of course. You can, like this one shown there, that's mild steel painted. We do them obviously in 304 stainless and 316 stainless. And although nominally the angle that these core screens are designed for is 75 degrees from the horizontal, we can make them at virtually any angle to suit the civils requirements. Everything that we manufacture from the green side of the business are bespokely made to suit customer requirements every time. So these screens that you see there, although if we had a crane available that was large enough, they could be lowered into the channel in single piece. Due to the site constraints, these are also designed to be split into 3 separate sections. So we have a bottom section where the grid bars is, and then the central section, and then the top head end will go on last. So these are, once the client has been to factory acceptance test them, they'll be split into 3 separate sections ready to be installed on site by our installation teams, and then obviously commissioned on site ready to operate. So once we've got the coarse screening done and we've stopped any large objects coming down the works into the fine screens, we've obviously got to think about what kind of fine screening we want to do. So my next slide goes to one of our first types of screens. So this is our dual flow band screen. Various companies have their version of the band screen. Ours is called Vanguard, and as you can see, we recently received the best performing band screen at the National Screens Evaluation Test Facility here in the UK, where we were able to get a screener's capture ratio of 95% when we have screen panels with 3mm perforations. So everybody was very thrilled with that. Obviously, our screens team, with our combined 90 years of screens design and engineering experience, paid off. We're able to get such a good result. So again, you can see screen widths and depth, 4 metre wide, and depth up to 20 metres. So we can go quite large, and we can go down to screens with a panel length of just half a metre for a channel just 800mm wide if needed. So we can cover quite a range of flows from, say, 100 litres a second right up to a couple of thousand litres a second. Again, because everything's bespokely made, we can design things to suit your Inlet Works and give you the best solution for any application. As you can see on the screen there, we try to make the screen so that any maintenance can be done from the cope level, so nobody needs to get into the screen channel on a regular basis to do any maintenance. All the wash water spray bars and nozzles at the top of the screen, same with the bearings and the chain adjustment, so very easy to keep maintained. And again, you can have the screens in carbon steel or stainless steel to suit your requirement. We also manufacture the Vanguard unit as freshwater intake screens if required. So these can be fitted with galvanic protection for seawater, with some sacrificial anodes if needed. So if you have got some clean water abstraction used for the Vanguards, they can also be used for that. We can also put an integral washing compactor inside. Once we get onto the next slide, I'll show you where that would be. The Vanguard can also be an eel-fish-friendly version, which is what people want when they're abstracting from rivers these days. So again, due to our designers being able to do everything from scratch, you can have what you want. We can sort out any requirement. Now the next slide should turn into our animation. Thank you, Robert. So this is the Vanguard being taken away. So you can see the main drive shaft and sprockets coming out there, showing what is inside the band screen. The yellow sections are the chain guides. So again, you have a pair of chains that run over the drive sprockets at the top of the screen. And then at the bottom, there are just some chain guides. So no sprocket in the bottom of the screen to grease or for them to wear out. It's just some chain guides. And the panels get cleaned of debris once they get blinded. So the next slide, but I was not too familiar with band screens. The flow enters the center of the screen, as you can see from the left hand and the center picture there. That's the dirty water entering the center. So anything that goes into the band screen will be taken out. Now, this is another reason why having a core screen protection up front of this type of screen is advisable if you do get some gravity inflow. Let's just imagine if you get something like a house brick or something like that into the centre of the screen, because you've got no core screen protection, then that tends to sit in the screen and gets partially carried up by the screen panels before dropping back into the bottom, potentially damaging panels over time. I've had screens in the past on different sites where construction waste from somebody doing some work in another part of the works has made its way into a screen. We actually had the screen trying to take out some reinforcement bar that somebody had been using doing some concrete work. So the core screen up front would have stopped the screen becoming damaged in that instance. So with the band screen, core screen up front always advisable. So as the dirty water goes into the centre of the screen, the panels become blinded until a differential across the screen is detected by the control system, and the screen is called to operate. The drive motor rotates the chain and takes the dirty panels past the spray bar mechanism. You can see on the left-hand side of the slide the spray bar, the circular spray bar, spraying through the screen panels. The debris is washed off, and the screenings debris enters that central collection trough, which then transports the screenings on water into screenings handling equipment. Now, what we can do with this unit is replace that debris collection trough in the centre of the screen and put the washing compactor directly inside the screen. So any debris removed from the panels goes directly into a washing compactor, where it is washed and compacted and comes out of the discharge tube. So it's a very compact unit if the site conditions allow for collection skips to be in the direct vicinity of the screen. Again, because everything's made from scratch, we can adjust. We don't have any, although we have standard designs, everything's adjustable. So just let us know your requirement on each time. The wash water on this particular unit can be final effluent if need be, providing it's filtered down to a 500 micron requirement, and we usually require 3 bar pressure for the wash water there in order to wash those panels off successfully. The next slide that I have coming up shows you the screen panels in a bit more detail. So what we have there is, you can see on the right hand section, is we've got a continuous set of panels mounted between 2 sets of chains, and between each panel we've got a sealing mechanism, so debris can't pass between the seals. And as you can see, the chain guide at the bottom of the screen in the centre picture, and the picture on the left is the large white blocks of plastic at the back of the photos. So as the chains go around the bottom of the screen, they pass underneath this chain guide. Again, as you can see, no sprockets, so no maintenance or greasing required. The next slide that we've got now shows that at the end of each panel is a plastic guide plate which seals the panel. So basically, flows can't get left or right of the panel. Everything's got to go through the panels, and these are made out of ultra-high molecular weight polyethylene, and very good wear-resistant properties, and it easily replaceable when it comes to any maintenance time, which obviously maintenance is how long is a piece of string, how long are you going to need to do between maintenance activities. You're probably looking at something like 10 years before you would want to change the chains and the side seals, but it really does depend on usually the levels of grit in the system as to how much those deals wear. So definite answers, a tricky one to give you, I'm afraid. But the next slide gives you a bit of a better picture of where those side seals fit. So we've got a side seal at each end of the panel, and then that attaches to the chain. The chains themselves running those plastic guides and thus seal the panels. So all the flow has to go through the panels and none can escape down the side. The next one. This animation just shows the panels coming apart. So that was the seal that goes between the panels first. That's the actual panel material. For sewage intakes, we generally use plastic, and for water intakes, we use woven wire mesh. And then, as you can see now, the chains and the side seals are coming off, just to show you how those all fit together. There we go. So that's our Vanguard type of screen. And like I said, that gets a very good score from the screening testing facility. And now we're going to move on to our other type of fine screen, which we call our Vanguard. Again, different companies have got a similar product to this one, and this tends to be the UK standard screen, the first choice type of screen to go for, and that's because it has a dual cleaning mechanism. We have a rotary cleaning brush and a wash water cleaning mechanism. If the wash water fails, the screen can carry on cleaning with just the rotary brush mechanism, which is why it being a UK standard, because a lot of sites were having problems with outdated wash water pump supplies. So with a band screen, if the wash water fails for a length of time, the panels become very blinded. When the wash water comes back on, it can take quite a while for the panels to get clean again. So when you get a fine guard, you get the rotary cleaning mechanism cleaning the brush, cleaning the panels, even if the wash water is off. Now these screens, probably the next slide's the better one to show you, because it's got a nice, you can see the water in front, so the panels actually sit perpendicular to the flows. So unlike the Vanguard, where the flows entered the centre of the screen and then went through the panels left and right, this flows hit the front of the screen head on. So the amount of flow that you can get through these screens really depends on how wide your channels are and how much water they've got. The panels in this particular instance are made out of stainless steel, again because they're going to be hit head on and they're going to be brushed. Stainless steel is a better material for that. This all works. Yes, it does. We've got an animation of this particular screen coming apart. Again, this is a series of panels mounted between two chains. There's sprockets at the guide sprockets at the top of the screen, and just some chain guides in the bottom, so no sprocket to maintain and grease any bearings in the bottom of the panel. I click onto how that animation's run through. This next slide shows it in a little bit more detail. So once the flows have gone through the front panel and the debris has been collected on there, again, once the differential across the screen causes the screen to start, that front band of panels is rotated up to the head end of the screen, where the debris is first brushed off and then water jetted off. Now what we do in the side plates of this screen, and you can see this in the bottom left hand corner 3D picture, you can see some large blue arrows coming out of the side of the screen. Because the screenings that were in the flow have been captured by the front band of perforated plates, we can cut the side of the side plate out and let flows exit left and right, and also out of the back band of the down-going clean back band of the panels. This means that we don't push all the flows through the down-coming clean band like some of our competitors do, so we can help minimise the total head loss for the unit as a whole. Again, these screens are available in a range of angles. It says there 70, 60 and 45. We have those as industry standards. Different water authorities in the United Kingdom have those as standard angles, but if your civils requirement needed us to make you a screen that was 62 degrees to suit, then that's possible as well. Vanguard and Vanguard selection, again, due to have you got wash water availability. If it's good, then you would be okay with a Vanguard. It is down to individual preference. Like I said, the UK water companies prefer the Vanguard due to the dual cleaning mechanism. Sometimes we have to go for the Vanguard type of screen if we are retrofitting a screen into some existing channels, because on the Vanguard the actual width of the panels is dictated by how wide the channels are, because they're perpendicular to the flow. On the Vanguard, because the flows enter the central part of the screen and then pass through panels left or right, we can have those panels, each of those panels could be, say, 3 meters long. So you'd end up with something like 6 meters worth of screening area, and you could have that in a channel that was maybe only 1 meter wide. Whereas with the Vanguard, if you had a channel that was only 800 millimeters wide, you'd end up with something like 600 millimeter panel width. So you might not be able to get all the flow through it. So sometimes when we're retrofitting screens, we have to go down the Vanguard route for that reason. If there is a definite requirement for a higher screener's capture ratio, say if you were fitting the screens before a membrane plant, then as you can see from the test results, you would go for the Vanguard, because with the 95% screener's capture ratio for the 3 millimeter holes, then that's what you would want, with no risk of any carryover of debris into the downstream flow. I'll just click to the next slide. It just gives you a bit of a closer view of the screen panels. This was taken in our assembly shop of the unit that is now actually at Severn Trent site in Netheridge, going through an extended trial with Severn Trent. As it got good results at the testing facility, so we're quite happy to help Severn Trent help us. So that's currently going through a field trial. You can see the perforated stainless steel panels and the profile that we got. The top right hand picture shows that the bottom of the screen is actually sealed, so no flows can pass underneath the screen. Everything has got to go through the perforated panels, and the white plastic plate that you can see on the top right hand picture shows that all the flows cannot get around the side of the panels either. So it's a fully sealed up unit. everything has to be collected by the screen panels. I don't know why not. So again, we've got the animation showing the side plastic seals attached to the perforated plates, and then attached to the chains to each side. Those last items with the teeth on that have just come off the animation, they are debris elevating combs, and we fit those to not every panel. Every so often we put a set of those on, and what they do is they can collect more of any screening rag that is in front of the screen, and that prevent rag rolling. Some of our competitors don't have those items on and rely on a very shallow angled screen being installed at say 45 degrees in order to prevent rag rolling. But with those items, we can install our screens at a very steep 70-degree angle and not suffer from any debris rag rolling in front of the screen. The next item shows where the washing mechanisms lie in a bit more detail. So the right-hand pic, you can see the rotary brush that sees the debris first and removes the majority of the screenings. Now, the reason why we don't put those debris elevating combs on every panel is they pass through the individual bristles on this brush. So the brush cleans all the debris behind the debris elevating combs and the rakes. So there's no debris left in the rakes. But if you put the rakes on every panel, the brush itself would wear out very quickly. So we only put them on every so many panels. So that rotary brush is rotating at around 100 RPM and cleans the majority of debris off the brush, off the panels. The band itself, if you're looking at that, again at the right hand picture, that's rotating in a clockwise direction, and the rotary brush is rotating in anti-clockwise direction, so the debris is being flicked down and back into either screen handling equipment located directly underneath the screen or into a launder trough to collect the debris. Once the panels have passed the rotary brush, they are then cleaned off by a spray bar. Again, this can use final effluent if that's what you've got on site. And again, filtered down to 500 microns and at 3 bar pressure. Yeah, the animation on that left-hand side is showing you how that just fastens together onto the brush drive motor. That is a brush end boss. So the actual yellow brushes come in 100mm wide segments. They all lock together, and then when you get to the last segment, we put on an end boss to lock the whole brush into place on the drive shaft, on the brush shaft. So going forward for spares, we can just supply the yellow brush segments each time, and the original brush shaft and locking collars can be used for the whole life of the screen. It's just the rotary brushes that need replacement, and they usually last 2 to 3 years before they need replacement. That whole unit is self-adjusting, so as the brushes wear, the unit itself moves closer to the screen panels, so the panels are always being cleaned off in an optimum manner. Now that's my last slide. So I think the next one is just saying if anybody's got any questions at this stage, now's the time.
Good. Well, thank you, Ed. Thanks for that in-depth knowledge and in-depth look into Spirax inlet screens that we have on offer. We did have a number of questions that came through during Ed's presentation, which Ed did cover, so hopefully those were answered. If anyone has any questions, feel free to type them in now quickly with regards to Ed's presentation, and we can address those. Or if you'd like to unmute your mic, feel free to join in the conversation and join us sort of live. We'll just give you a minute or so just to see if anyone's got any questions. Otherwise, we'll move on to the next presenter and presentation. Right. Ed, anything else before we hand over to Bruce?
No, I think we'll pass on to Bruce and let him give us his knowledge on the other products that we've got to offer.
Good. All right. Well, thanks, Ed. Well, we'll move now over to Bruce Crawley, our product developer here at Spirac. Bruce has more than 15 years experience within screenings, washing and grid classifying. So without ado, Bruce, over to you.
Okay. Thank you, Rob, and thanks, Ed, and thanks for everyone for joining in. Just bear with us for a moment here. Well, this is our first attempt at this, so if things are a little... Okay. I want to talk to you today about mainly primary wastewater treatment plants. Ed's spoken about the first stage of protection for your wastewater treatment plant. I want to talk to you about things that happen downstream of that. I also want to talk about alternatives for smaller plants and then larger package plants as well, because Spirac do all of those combinations. Starting with those, I'll talk about the SpiroGuard family of products. SpiroGuard is a range of screening and grit removal products. The one you're looking at currently is it's basically a primary treatment plant for pumped inlet works, where all you're trying to do is get the screenings out of the water. So this is a tank-mounted channel screen, if you like, or a spiral sieve, as often gets called. Couldn't be a simpler device, really, for removing screenings. It's got a pushing arrangement with a shaftless screw conveyor up the middle of the tank. There's a screen underneath that, which may be a wedge wire or a perforated screen, depending on what size of straining you want to be able to do. You have a pumped inlet here in the back of the unit, so it pushes water through, the water passes through the screen, and then it comes out the bottom. There's a level sensor within the tank itself that activates the gearbox or the motor on the gearbox, and that will clear screenings off of the screen itself. There's a brush attached to the spiral, and that ensures that the screen stays clean. This port here is an overflow port, so that's for emergencies only if the screen should block for some reason. So very simplistic unit, economical, and these can handle up to 150, even up to 200 liters per second. So they can be grouped together and create a fairly sizable plant. And they can come in 2 to 6 millimeter perf or wedge wire down to 1 millimeter, so we can achieve quite a fine screen process with this. Just waiting for the slide to advance. It's a little bit slow. Also, if you, I think Ed's accent was kind of a clue as to where he was speaking from. My accent may be not as obvious as that, or it may not give you much of a clue. You might be wondering, well, is it Canada? Is it America? I'm actually in Australia right now. So we're truly an international company, and our head office is in Australia, but we have factories in the UK, in Sweden, in the US, and in Australia. This is a see-through view of the CC unit, so you can see the simplicity of the screen arrangement with the spiral, and you can see capacity of wet screenings up to 3 cubic meters per hour, substantial weight reduction up to 80%. These are suited to having a press head on the end of them, so in addition to just removing the screenings, we can also compact them and achieve a good screenings reduction. This is a photo of a unit. These are well suited for remote sites, which this one is, simply because they have one moving part, so they're very foolproof and really work effectively as a low-cost primary treatment system. You can see the press head on here. So that's got a door on the end of it with a spring hinge arrangement, and that creates a plug in the end, and that creates a back pressure to push water out through a basket screen at the end of the conveyor. We can have wash water on these or rinse water to help get a certain amount of cleaning, but these are not as effective at cleaning screenings as the next products will show. These can be mounted on top of classifiers. So when I talk about primary treatment, we may be talking about screenings. In this case, we're talking about screenings as well as grit. So CC units, in this case, 2 of them twinned together and piped in parallel, can sit on top of a classifier. So after the influent is passed through the CC unit, it will drop into the classifier, and the grit is removed from the stream as well as the screening, so that you get a complete primary treatment out of quite a compact plant. And these are quite convenient to service and can be replaced one at a time. So it is a very easy to operate and low-cost type of installation. In this instance, we've got long opaque bags, or Paxo bags, which are an endless bagging system, and that ensures that any screenings or grit are contained and odor-free. They're not exposed to the air, so these plants are quite low odor emitting. Okay, this is a view of the same plant in the factory, so you can see the twin-mounted CC units on top. In between them is a bypass tank, so you can have a manually raked bypass, which is quite a common feature to these, just to allow a bit of backup. These types of screens can also be applied in channel flow type of arrangement. In this case, we've got gravity flow in concrete channels. You can see there's a septage truck that's dumping its load and feeding into the channel, and these work on the same basis as the CC unit, except that they're not tank mounted. So these will work quite well under gravity flow and achieve the same effect. So again, these can be twinned or tripled together to get flows up to 300-400 liters per second we've seen. They can be used in industrial applications as well, but most of these are used in wastewater sewage treatment plants. This is a closer look at the brush system and the screen system. So you can see that we can, in this case, the brushes are welded to the spirals. There's twin brushes in this case. We can have either twin or single, or they can be pinned in place rather than welded to make them a little easier to change out. It's arguable which is the best way to do it. Different plant operators have a preference one way or the other. These also feature baffles on the side to prevent bypass of water, and you can see you get quite an effective removal of screenings from an effluent or an influent flow. So again, a very cost-effective and reliable single moving part type of process. Another product is a step guard, which is a step screen. I'm not going to go into much detail on these. It's a product we don't sell in the UK particularly, but we sell it in other parts of the world. And we have competitors that sell this product as well. And it works a bit like a rake screen in that you have slots rather than perforations for your to filter your influent. And screenings are stepped up passed up the stairs like an escalator and dumped out the back into a conveyor or a wash press. The benefit of these screens primarily is that they have a large free area, so they have a lot of open space for bar space, so you can get a lot of flow through them in a small channel. And they operate on the principle of having a mat on the face of them, so that's how they gain efficiency. Once we collect the screenings, it's a matter of what are we going to do with it. So So there's a couple of options. One of them is a spiral press. One is a spiral wash. So they do similar functions. Spiral press we kind of spoke about because it was part of the assembly for a CC unit. So it's got a press head on the end. It's just a simple single screw that feeds into the press head. So this is either a wedge wire or a perforated basket with a spring door on the end, and a plug builds up in the end of the press zone, and that allows water to be squeezed out through the perforations or the slots and drains back to the drain box at the bottom. This doesn't have much washing effect, but it's a very economical and effective way of compacting screenings, and you can get about 80% compaction with that, with a single screw, single gearbox arrangement. So these are quite popular in the UK. We've sold many of them over the years, and these can go up to a size 440 diameter spiral, so they handle a large capacity of screenings. They're often used as a backup to what we would consider to be a more efficient and effective washing system, which would be our spiral wash unit. So the spiral wash differs in that we have a shafted screw in here, we have a very high torque, high power gearbox, we have a very robust press zone in here, and to get our back pressure on these, we put on an elbow or a series of elbows that forces the screenings to go around a corner, and that creates back pressure on the press zone, and you get a high degree of compaction. Also within here, the press tube is a wash zone, so we have spray water that goes into the press tube, and that rinses off screenings. The spiral moves forwards and backwards to allow for a cycling and a washing of the screenings, and that's what gives us our washing effect. These are, there's 4 sizes of these, from 1 up to 8 cubic meters per hour of uncompacted screenings. These are also available in duplex units, so they're twin screws in a single chassis, so that takes you up to a capacity of 16 meters cubed per hour, and that's in washing mode. So if we want to have a peaking factor where you don't get the same amount of washing, you can go up to about 25 meters cubed per hour on a twin unit. So these have very high capacity and are very effective at cleaning screening. So these achieve about an 85% compaction or volume reduction, and we'll end up with about a 45% dry solids outcome, which is about as much as what you need for most landfill applications. There are alternatives if you want to get even cleaner screenings than that. We do have a bolt-on assembly, which is I'll come to it in a minute. That's just a view of the compact spiral wash unit, so you can see it's quite a small footprint. Here it is sitting as a discharge to a screen, so it's direct feed from the screen into the inlet of the spiral wash unit. Very compact installation right over top of the channel. This is an installation with a Vanguard. So the Vanguard sits in the channel. Got a very short launder which feeds into the top of the spiral wash unit, and you can see in here we have quite a large drain box. So we put a large drain box on these when there's when it's launder fed. So we've got a lot of loose water coming into the spiral wash unit. We want to be able to drain that off as a first stage of washing, and then so we get rid of all the loose water before we start compacting it in the press zone and adding more clean water to it. After that, it passes through, in this case, quite a gentle elbow in here. These can be anywhere from maybe 20 degrees up to about 70 degrees as a first turn, and we can get lifts up to about 3 or 4 meters and runs maybe also 3 or 4 meters. So we can cover quite a distance just in the traveling plug that travels from the discharge to your skip bin. Here's another example of a more aggressive type of discharge. So these are larger units. These are 365 size units, which means the spiral in these is 365 millimeter diameter. So these handle a large throughput of screenings. In this case, the screenings come out discharged as a plug, and they turn that first corner, and at that point you are creating a lot of back pressure on the press zone. So what you're doing is you're putting a lot of force into the plug that's in here, you're squeezing all the water out of it, and you're getting quite a dry and unrecognizable plug of screenings that will now travel up here, continue on up into this drop box. So this drop box is just a transition from horizontal to discharge again. So it travels out of the drop box and down through this bifurcated chute to choose either conveyor A or conveyor B according to the position of the gate in the bifurcated chute. Now, when the screenings come out, they're quite dry and hard, so their tendency would be to push straight into that back wall. And on these instances, we have a plug breaker up here. So in this case, it's a pneumatic ram, and what that does is on a timed cycle, it strokes down with a guillotine effect to knock the end of the plug off to allow it to drop down into the screw conveyor down below. So Spirac is best known for over the years for shaftless screw conveyors. So these systems are generally feeding shaftless screw conveyors or some other form of collection system. Here's another view of an alternative technology. So this is again a band screen with a launder feed. And instead of going straight into the spiral wash unit, it goes into an angled screw conveyor. So instead of draining the water in the spiral wash unit, we drain the water in a drain box here on the bottom of the conveyor and then transport the screenings uphill, and that allows the screenings to dewater, and you're putting, not dry screenings obviously, but you're not delivering all the loose water to the spiral wash. So that's got some benefits in being able to control your where your water is coming off of your screenings, and it allows you to have a smaller drain zone on your spiral wash unit. So I guess the point is there's a lot of different combinations that these can be provided in. Here again we have the conveyors discharging into bifurcated chutes. So now they're feeding into the spiral wash units, either A or B, feeding the discharge tubes. And you can see we've got quite a high lift on here again, and up here you can see our plug breaker arrangement once again. In this instance, what we're feeding into is a spirotainer. Now, not everyone will be familiar with spirotainers, and I'll talk a little bit more about that in a few minutes, but that's another auto-filling bin system, which we sell a lot of. As I was mentioning earlier, the quality of screenings we get off of a standard spiral wash unit is quite high and generally suitable for most most landfill sites in the UK or in most other jurisdictions. But there are instances where people want cleaner screenings for some reason. So we have what's called our high impact spiral wash unit. So that's like a washing machine that sits on top of the spiral wash. So that gives us a two-stage washing process. So within the high impact zone, there's a high impact impeller within there that acts like a bit like your laundry machine at home. Although if you put your clothes in this, I think you'd come out without any buttons or seams left in it. It would pretty well destroy it. It's very aggressive. So it truly separates any potential organics that are left in the screenings. It also breaks up any paper products and gets rid of anything that's a little more resistant. And it kind of changes your fraction of material that goes through back to your biological processes compared to what continues on into your skip bin. So it has to be applied with care and consideration to how you want to separate those solid streams. And this is an example of what the final product looks like. So these are screenings plugs, and they're almost unrecognizable as being screenings. When these end up at the landfill operator won't know where they came from or what they were. The ones in the back here were before the washing was turned on, so you can see that there's a distinct whitening of the screenings as they pass through. This gives you an idea of the aggressive impeller that's on that. That's not like your washing machine at home. And the SpiroPress dewaterer then is, as I mentioned, is another alternative to that. It's a less expensive, less sophisticated controls, very simple operation, a single spiral with a press zone at the end. And some shots of how that works. So there's a press door to create a plug. This is a view of the wedge wire basket that sits inside the press head, and just the discharge end of the unit. That takes us on to grit vortex systems or grit systems in general. Spirac have a couple of different alternatives for collecting grit. So we're kind of going in the order of the process here. The screens come first. We always take the screenings out of the plant. The screenings get washed. As the influent travels further downstream, it's free of screenings now. And in most plants, we have to be able to get rid of the grit. And that the degree of separation that we want depends on what the downstream processes are. For plants that rely on membranes or or very fine filtration downstream. You want to get rid of as much grit as possible. And to do that, you would tend to want to apply a grit vortex chamber. So a grit vortex is a system whereby we turn linear flow from a channel into rotational flow in a round chamber. And what that allows is for grit particles to travel to the outside of the chamber, slide down the wall of the chamber, down the 45-degree angle, and down into the collection sump at the bottom. So the grit particle is under it tends to want to travel in a straight path, so it wants to travel to the outer wall of the tank, and where it will get into a low flow situation, and that'll allow it to travel down the wall. Also, the distance that it travels and the residence time that it experiences, which is about 30 seconds from inlet to outlet of the tank, is enough for the gravitational force of larger particles to drop down below the discharge. So there's two modes of separation. So those two modes will end up with all of your grit separated out and in the bottom sump. There's an impeller on here, which is a continuously rotating impeller. It rotates in the same direction as the water flow, and its single purpose in life is to re-entrain the organics into the wastewater stream. You don't want the organics settling out into the bottom sump where you get a slurry of muck down in the bottom and it becomes difficult to extract and treat the grit afterwards. You want that grit to be separated from the organics. Plus you want the organics to stay in the discharge of the unit, because that's what the downstream biological processes rely on. So this is a slowly rotating impeller, turns about 15 RPM, and that creates vortices within the tank. And what that does is swirls up the organics and the lighter particles and the larger particles, keeps them suspended and keeps them moving to the outlet of the chamber. These chambers are either built out of concrete, and these can get quite large, so a system that will go up to about, say, 6,500 liters per second might have an 8-meter diameter tank. So quite a large footprint on a plant, but quite an effective and simplistic device for separating out grit. Smaller ones can get down to as small as about 2 meters in diameter. So we cover a range of maybe about 35 or 50 liters per second up to 6,500. Smaller ones up to 3.5 or 4 meters in diameter can be made out of stainless steel or painted mild steel, the tank assemblies. So that means you don't have to have all the civil works to it. So that works well if you're combining it with a stainless steel channel system built up above the ground, and is a much more low-cost and effective way of doing it. Removing the grit from the sump, there's 3 different alternatives. You can either pump it out with a flooded suction grit pump. So this is where the pump sits down below the water level. So if you have a stainless steel tank, for example, that's above ground, it's very easy to have the pump sitting down below grade, and you have a line that goes into the bottom of the sump, and it just simply draws out the grit slurry and sends it off to the classifier or grit washer. The grit can sit in there, and it can sit and not solidify, but it can become difficult to extract if it sits for too long. So before you turn on the extraction pump, we tend to want to fluidize it. So we send a blast of clean water in to stir up the grit, create a grit slurry, and we can draw it out and then pump it on. So that comes through the side of the bottom chamber of the sump, and nothing passes up through the tube of the vortex assembly. An airlift pump, on the other hand, sits up above the channel, and the way the airlift pump works is it's a rotary low blower system, and what it will do is it will send a blast of high pressure air down through a center tube, which feeds a second tube, which is the extraction tube. So there's a larger tube in here, which is about a 100 mil diameter pipe, and you feed a blast of air into the side of it through this inlet collar, and that creates a bubble effect. So the bubbles travel upwards through the extraction tube, and what that does is it creates a lift effect, creates suction in the bottom, and that will draw out sand and water in maybe a 5 to 10% slurry that again passes on down to a classifier. These are used in preference to pumps for a number of reasons. There's no impeller in the grit slurry stream. Impellers wear quite badly handling grit. Even though these things are low hours, they only run maybe an hour a day or 2 hours a day if you've got a high grit load. The advantage of the air blower is that it doesn't see any grit. The pipe is just an empty pipe. The grit and water travel through the pipe without any other devices in line except maybe a control valve or a shut-off valve. So there's very little wear happens with these systems. The downside is this can't provide much lift, so if your classifier is up at a higher level, then you may not be able to reach it with this application. But for systems where you've got the classifier or the grit washer at a lower elevation from the tank, then that will work absolutely fine. For fluidizing, there's a third line. So we send a blast of air down into the bottom of the sump first. That churns up the water, it turns up the grit again, and allows it to extract it as a slurry. And the third option is a self-priming grit pump. So this is just like the flooded suction pump, except it sits up above the channel, so it needs a self-priming sump on the bottom of it to allow it to draw water up because it's up above the channel water level. But the fluidizing process is the same. Fluidizing line comes in from above in this instance, and it may just be plant water under pressure, it may be pumped water, or it may be water that we draw off from the discharge here and feed back. So there's a variety of options for that. The elegance of it is that it's a simplistic operation, and these things will run for many, many years trouble-free, and they're very forgiving. They handle low flow rates, they handle high flow rates, and because the impeller, the relative velocity of the water over the impeller slows as the flow drops down, that means you have a greater impact from the impeller. So slow flows with longer residence time means that the organics still stay in suspension, even down to zero flow rate. This is a view above with a redundant set of grit pumps. So these are these are self-priming grit pumps. These are belt drive. These are high RPM, high grit handling capability. This is a view down to the impeller, so that's the rotating part. This hollow pipe is a rotating part of the assembly. And another alternative, generally for larger plants, but can be for intermediate size, are an aerated grit chamber. So this is a similar mechanism for allowing grit to settle out of water by means of residence time only in this case. So what happens is this is an oversized chamber like a swimming pool. Water travels from the inlet to the outlet end of the chamber, and the amount of time it spends in there is such that it allows grit, all of the grit to settle out to the bottom, where a slowly rotating spiral screw turns and it draws the grit backwards along the bottom and to a discharge sump. So this sump gets pumped out periodically, and this is a very reliable and effective form of grit separation. These can be up to 35 meters long, these screws with a low power gearbox on the end of them. It's very low friction operation in here, so quite effective. There's a puddle flange in here which separates like a dry mechanical room from the tank, and then with the discharge chamber down in here. So quite a simple operation. We sell lots of these, but they tend to be the larger plants. In here you can see the aeration system. So the aeration system in here is generally to allow the water to circulate, so it keeps traveling in a circular motion, and that allows the organics to stay suspended as well. Again, you don't want the organics settling out into the bottom chamber and getting entrained with the grit. It creates a terrible slurry mess at the classifier, and this ensures that even under no flow conditions you keep the organics suspended and moving down the length of the tank. And where do we send the grit to? We send it either to a classifier, which is just a simple device, which is a tank. Again, we're separating out grit from water. The difference in this case is that our grit stream coming into a classifier is highly concentrated. So it might be 2 to 5% grit, whereas what a grit vortex sees or the grit chamber sees is maybe 1/100th of that concentration. So what we've done is we've separated out the grit, we've concentrated it into a slurry, now we pass it into a classifier, so we can now extract the grit out, drain the water off, and discharge it into a skip or into a spirotainer. So a very simple device, again, one rotating screw which transports the grit uphill and into the skip as shown here. Very simple controls. These will typically operate on a time cycle and again run an hour or 2 hours a day depending on the grit loading of the plant. An alternative to that is if you need cleaner screenings at the landfill, or cleaner grit, we can apply a grit washer, which does a similar process as the classifier, except that what it does is it washes the grit as well instead of just transporting it. So it operates by developing a bed of sand in the bottom section of the grit washer. It passes a stream of water through there's a diffuser plate in the bottom here, a sandwich layer of perforated metal and impermeable rubber, and that allows a constant velocity profile across the bed, and that allows the grit bed to fluidize, and in that fluidization process the particles rub against each other, and that friction is what breaks off the organics, the organic particles from the grit, and that floats them upwards and up into the water portion of the tank. So there's a water layer up here above the grit bed, and that water then builds up with organics, and periodically the organics discharge is open and we decant off that water and we end up with a clean slug of grit down here. Once we've done that process, we turn on the grit screw and we transport that clean grit out to a discharge into a skip. So it's a batch process. There's a pressure sensor down here, detects that the grit level has dropped, and we're ready to receive another batch of grit slurry. So the pump will come on at the grit vortex, feed the grit slurry into the top of the unit. Water will overflow out a weir, and sand will settle down into the tank to start the cleaning cycle. So quite an effective way of washing grit. And again, these operate on a batch basis, but these are low operating hours as well, again, depending on the volume of sand you've got in your plant. So these can go a half, 1 or 2 tons per hour of washed grit. And that's one in real life. And again, feeding a spirotainer, which I'll get to shortly, in fact, immediately. So the spirotainer is a self-autofilling road transport and fully contained storage system. So it's intended for handling offensive materials. So it's for screenings and grit, either separately or combined. And it's connected to your plant by means of a retractable chute, typically with an odor seal on it. So the intent here is that this is a completely odor sealed and negative pressure system, and that keeps all odors contained within the spirotainer or within the conveyor system that's feeding it. So there's no potential for odor escape if you've got one of these in your plant. In this case, we've got a rubber seal up on here, a retractable slide gate, and a very heavy rubber door seal on the end. These get put into plants in parallel or in series, and can be fed by a conveyor, or they can be fed directly by a spiro wash or a classifier. In this case, we've got 3 in a row, and these are automatic retractable chutes. So the system allows for a pneumatic actuator to close off this chute, create a tight seal against the spirotainer. The spirotainer, by means of a screw conveyor along the top of it, fills the bin. It's got multiple discharge points so that you get an even filling of the bin along its length. So that creates the auto-filling aspect of it. So that allows you to fill either 10, 15, or 20 cubic meter bins full of screenings or grit. And then when a hook lift truck comes in and picks these up and pulls them away, the gate on the top is manually closed, and that allows you to remove the spirotainer, and the odor containment is still maintained. So a seal is still maintained on the spirotainer, so even as the truck leaves the plant, there's no more fugitive odors can escape from it. So it's truly an odor containment system, and it allows that the operators never see the screenings. And if you visit these plants, it's very hard to even tell that they're a wastewater plant, because you just don't see any screenings, you don't see any grit, and the odor levels are remarkably low. These can be built in stainless steel. Price of stainless has come down over the last few years, so we're now starting to see that these are economically viable to be built in stainless. They live a hard life. The paint on these needs to be very robust. They get handled by contract trucking companies, so they have to be built like a tank, and these are. So the stainless steel just gives another level of protection against corrosion. These should last 10, 15 years in normal operation, and then we refurbish them after that to get another 10 to 15 years out of them. These are 20 cubic meter bins. Again, these are on load cells, and these are actually handling sludge. So these can be set up to handle sludge instead of screenings and grit, but the more common application is definitely the screenings and grit. Got a video clip of how these work. There's sound on these, but I don't think the sound's going to work on your end, so I'll just narrate over it, much to your enthusiastic response, I'm sure. Okay, so this shows actually the last slide we saw of the sludge system. So that shows the slide gate. It's going to be hard to keep up to this because it's been sped up, and it might be a little choppy on your end. I'm not going to be able to keep up with it, but it does show how the truck comes in and picks the bin up, so it shows the hook lift arrangement. Shows the order of the removal, so obviously these have to have power and control wiring to them, so that truck is not going to take that bin away until the operator's been out to disconnect all the power cabling and also the retractable chute. So there's a procedure he has to go through to make sure that he doesn't get the order wrong and drive the truck away first before disconnecting everything else. We've seen that happen, but it only usually happens once, so, and they learn. So he closes off that to maintain odor containment, and then pulls it up onto the back of a truck. So these are big bins. These are 20 cubic meters, or a total load of about 25 tons that are it's going up on the back of a truck. So these are special trucks for this application with triple axle. And so he's got a remote control here to pull it up onto the back of the truck. And it runs along on rollers on the ground until it interacts with the truck rollers. So these are the same sort of systems that would be available in the UK, and we think there's a market there for this product just for the reasons I've outlined already. Mainly odor containment, both at the plant level and as you drive through a populated area and down the freeway. These have a very robust door containment, very leak-proof design. You don't want any water coming off the back of these units if there's any loose water in the screenings or grit. So we pay a lot of attention to ensuring that that seal is robust over a 10 to 15 year life expectancy. So they get dumped at landfill, or in this case at a composting site, and it's just a matter of tipping that truck and dumping it out the back tailgate. It's a ratchet system to keep the door tight. The seal against that rubber, as I say, is very critical. So that ratchet system is quite important. It's got 3 points of contact along the bottom, 4 points of contact along the top, so it's guaranteed to not leak. So as you can see, that's sludge, not screenings, but same principle applies. And I think I'll skip on to the next slide. Okay, I just want to talk a little bit about packaged inlet works, or complete built-up systems, and we do a lot of these plants. So we do a complete primary treatment system. So these can be a variety of combi guard types. So a combi guard is just referring to a primary treatment plant. So it can be screenings and grit plus fat oil grease, and it can be a self-contained tank system like this, which we call our combi guard unit, and which has a screening section, a screen in it, and the screens can be any one of the ones that you've seen so far, and then a grit separation, and can feed straight into a bin or onto a washing unit. This is a system where we've got 3 CC units feeding into a common discharge. We've got a vortex unit on the discharge of that feeding into a sand wash unit. So this is quite a complete plant that gives a complete primary treatment. And I've got a little animation of this as well, which is, I think, quite cool. So this is an actual installation that we've had modeled, and you can see there's 3 SpiroGuard or CC units on the top, also a manual bar screen. So wastewater comes in here, feeds into 2 out of 3. The third is a standby unit, 2 out of the 3 CC units, and is then passed on to a vortex unit. So I'll let the pictures show it better than I can explain it. That's the bar screen. So that's a manual bar screen for emergency purposes only, or for servicing the CC units. And this is a CC unit, so you can see the water coming in, screenings going up the shaftless screw conveyor into the press head and into the discharge port. So that's a very simple operation. Again, these just operate on level control, so those spirals only turn whenever there's screenings built up on the screens. So they'll last a long time before liners or brushes need to be replaced because they're very intermittent operation. These can then discharge straight into a skip bin or into a spirotainer. They can be washed, they can pass into a wash press, or in this case they're just going through a press head. And then the screened water passes through into the vortex. So this is a stainless steel assembly. So we build that full application in our factory and ship it to site. So that might come in 2 or 3 pieces to be site assembled, or a single piece if it's small enough. And then again onto the grit washer, the sand wash. Okay. Okay, sorry. Just about at the end of this. So another representation is another type of combi guard system we have, where we provide a channel system. So the channels are completely built out of stainless steel in the workshop, assembled at site. These, in this case, have drum screens feeding into a vortex, and again feeding into a sand wash. And this is an actual job as well, so you can see what the installation looks like in real life. Let's put that onto full screen. So these are typically elevated to allow gravity to work on your favor. So it's pumped inlet with gravity feed outlet. So these are elevated in this case to about 4 meters. And this is a plant where we provided everything you see in that photo is provided by Spirac, the support structure, all the inlet chambers, all the components. So this is where we specialize on this type of packaged plant. For complete screenings. So this has advantages over a concrete system. This plant is expandable, it's movable, it's less expensive, it uses less real estate. You can still use the land underneath the tank for various other elements of the wastewater system. And so it's quite an effective way as an alternative to a civil works type of plant. You can see the screenings going up the drum screen and coming out free of screenings and onto the grit vortex system. These systems are for municipal wastewater treatment plants. We don't sell them particularly for industrial applications, although some might be suitable. So that's representing screenings coming out of the system and going into our spiral wash unit, where it gets washed and compacted. So this gives a more graphical view of how that operates. That cycles back and forth. It doesn't necessarily show it in the graphic, but you can see the interaction between the spiral and the screenings, and then the discharge of the plug. So this is one where we're feeding straight into a skip bin as opposed to a spirotainer, but happens much the same way. And the grit vortex section, you get a good animation then of what the water flow is like in these and how the grit particles settle out into the bottom of the sump. So that's better than I can describe it. You can see the grit collecting in the bottom and then getting removed by the grit pump and sent to the grit washer. So quite a slick animation, I think. And then sitting in the bottom of the grit washer, there is an impeller in that which provides agitation and keeps it stirred up. And that's the plant in real life. Okay, and on to our last slide is a new plant that we're building in the UK. So kind of combines some of the features that we've seen in here. It's probably a higher grade plant because this has fine screens, Vanguard screens across the channels. These are all stainless steel channels, so this is all an elevated platform situation where we've got our inlet chambers, pen stocks, fine screens, then traveling downstream, turning a corner and going up to the grit vortex unit, and then discharging back down into there's a downstream weir and like a discharge box at the end of the plant. This is feeding grit into a classifier and feeding screenings into twin spiral wash units, which are then feeding into skips, which is a typical UK type of arrangement. So some big pluses. Everything's above grade in this. There's no civil works involved aside from the footings for this plant. It can be moved. It can be easily expanded. Very easy to service, and is a lower first cost than most concrete or civil works type of plants. So that brings me to the end of my section. If there's any questions or anything, or anybody wants to add anything to that, I'll turn it back over to Rob.
Brilliant. Thank you, Bruce. Thanks for that. And yeah, some good imagery there and some interesting details. Is there any questions from anyone else out there that's listening? I see there's a question coming from Felix asking what sort of market these installations are for, whether they be municipal or industrial. Typically, they are municipal. And yeah, so we do other, or our products are transferable to other industries. So we do a number of wineries, slaughterhouses, distilleries, a lot of paper and pulp industries use our products in a different shape or form. But generally, the Inlet Works are for municipal sewage treatment. Are there any other questions from anyone else? Anyone else want to type something in or chat over their microphone? No? All right. Well, then we'd just like to say thanks to everyone for your participation in our webinar, and hope to see you guys soon. Just a few things. We are exhibiting at Utility Week Live on the 22nd and 23rd of May here in the UK. So if you are local in the UK, do pop along and see us on our stand. And also pop along over to our website where you can get sort of dates and details of all other exhibitions we're doing around the world, and any sort of latest news on new projects and products. Thanks everyone, and take care.